In today's lesson, we're going to give the player the first clue for the Hangman puzzle, the number of words in the phrase and the number of letters in each word. The number of words and letters in a phrase can be determined by locating its blanks. Java can get the character at any position in a string, but it returns character data. Character data is another data type that we haven't used in our previous lessons. In this lesson, you'll learn about character data as you search for the blanks in the Hangman phrase. Hi, I'm Annette Gotland. I'm the author of the Do-It-Yourself Java Games books. I teach Java programming through creating games. Welcome to the video version of my books. We're currently in the Text Games video series, TG, the first of 4 types of games series. The focus of this series is to cover the fundamentals of Java programming. You'll learn how, when, and why Java programs are written the way they are. This series has 16 projects. Each project assumes you already have the skills taught in the previous projects. A link to the entire Text Games playlist is provided in the description below. We're currently working on the 15th project, TG15, Hangman. You'll be given a puzzle that shows how many words are in the phrase and how many letters are in each word, like this. If you guess a correct letter, the puzzle will show every place it's used in the phrase. If you guess an incorrect letter, that letter will be added to the list of wrong guesses, and another part of the stickman will be added to the hangman gallows. The object is to guess the phrase before all 10 parts of the stickman are drawn. This is lesson TG15.2, where you'll learn to use the character data type as you figure out how to print the hangman clue. In previous lessons, we used string data to examine and manipulate the string contents. In this lesson, we'll use character data. But what is character data? At first, character data might look similar to string data, but it is quite different. Character data can only be a single character. Characters are declared as char. Note, char must be typed all lowercase, and you must use single quotes instead of double quotes around character data. For example, to define a character variable named my first initial as an A, use this. And you must compare character data like you would compare integers. You must use the double equal sign, less than sign, greater than sign, etc., instead of calling methods like equals as you do with strings. Strings char@at method should be used to get the character at an index of a string. For example, if the string named greeting is set to hello world, you can check if the letter in position 1 is an E like this. String greeting equals hello world. Char C equals greeting.char@1. If C equals E, print found E in position 1. Let's choose a phrase for our puzzle and create a method to give the clue an initial value. I'll refer to this method as blanking out the clue, even though we won't actually blank it out. We'll indicate any non-space character of the phrase with dashes. Exercise 1. Create a method to blank out the clue. Pause the video if you need more time in any of these exercises. If you want to see how I would complete any of the listings, please refer to the completed listings at the end of this video. First, create a new private method named blank out clue. It should take no parameters and return nothing. Then, at the start of the constructor, set the phrase to hello world and call blank out clue. Run it. What happened? It should still print the puzzle the same as it did before. How do we blank out the clue? The blank clue should have a dash for each letter in the phrase and a space for each space in the phrase. Let's make a plan for our code by adding comments for how to blank out the clue. Exercise 2. Make a plan. Add comments to blank out clue for each of the required steps. Start with an empty clue. For each letter in the phrase, if the letter is a blank, add a blank to the clue. If the letter is anything else, add a dash to the clue. Then, write the code. Exercise 3. Write the code. Write the code to do each of the steps in the comments. Hint: use strings char@at method to get the character at each position in the phrase. Hint: use single quotes around the comparison character. Run it. What happened? It should still print the puzzle the same as before and should report no coding errors. So let's finally print the clue and see if it generated the clue as expected. Exercise 4. Print the clue. Add code to the last print statement in print puzzle to print 10 spaces and the clue. Run it. What happened? If you had set phrase to Hello World, it should have printed 5 dashes followed by a space and 5 more dashes. You should see the clue lined up with the row of wrong letters. Key points and more. Character data type. Character values are always a single character. They may be alphabetic, numerical, or other types of characters that you may find in a string. Declare character data as char. Char must be typed as all lowercase letters. You must type character values with single quotes like this. Char initial equals A with single quotes. Characters are case sensitive, so lowercase a and uppercase A are not the same value. Get a character from a string using string's char_at method, giving the index of the character. Use integer comparison operators such as the double equal sign, greater than sign, or less than sign to compare character values. Here are the completed listings for all the exercises in this video. This is the end of the second lesson in the Hangman project. We can now display the clue. In the next lesson, we'll update the clue for any letters guessed correctly. For that, we'll need to use another version of string's index_of method.